right. Everybody done? The check-in? Okay, so again, take notes of anything that you need to work on. All right, that wasn't clear. We're going to work on VLANs today, Wednesday. Next week we'll be doing inter-VLAN routing. So we'll have some time. We're actually going to try to do some review today because I had some requests for some different reviews. So we'll just, again, do a little bit of review. See where we're at with things. Let's see. All right, we're going to start with an easy one today. Octets, positional value, and subnet masks. So it'll just ask you, like, what octet is this in? What's the positional value? What's the subnet mask? Okay, so just a review. And hopefully everyone does good, but this should, again, just kind of let you know where you're at if it's something that you need to work on. And then we're going to do a VLSM today, too. And we'll work on it together. Okay. Seven, 8 of us. Warming up the brain. $224 plus 10. When your wage on? That one's on too, if it helps. Right, so remember we have some of those easy patterns. We've got a worksheet back there if you need one to help too. So what's the subnet increment? So you got to know the positional values, right? What is going on? Let's see, how'd we do? Yeah, so the /30. So with these ones, it might be a good idea just to have your positional value chart ready, right? That way you can see what the value is for your subnet mask. 128, 64, 32, 16, 8, 4, 2, 1. So the /30 lands right there. Does everyone remember that? Okay, perfect. Yeah, so let's see, the last network bit falls right here on the 32, right? We see where that last network bit is. So again, if any of these are giving you trouble, write it down so we can help. what is the network address? Looks good. So you have to know the increment, right? You have to know the increment, and then you add that to the octet. Strange. Ooh, what happened there? Let's see. So it's a 24, right? So all the network bits will be on in the fourth octet. 172.16.0, 255. 255. We'll practice those. So notice this is how many hosts are available. So you should have your chart out. 1, 2, 4, 8, 16, 32, 64. Right? So let's do that real quick too for anybody that hasn't done this. If we do the 1, 2, 4, 8, 16, 32, 64, 128, we'll just go this high, right? So these represent what? What are they? Positional values are the hosts. So let's, in this scenario, let's call this the hosts. Now it would be total, right? And then we want to match this up to the subnet mask. So we're going to match these up. Now I usually go 2 octets worth, 1, 2, 4, 8, 16, 32, 256, 5, 12, 10, 24, 20, 48, 40, 96, 81, 92, right? So 28, 27, 26, 25, 24. So what was our question? How many host addresses are available for /24? So I can look for my /24 right there, and I can see the total number would be 256. But what do I need to do?
Subtract 2.
I have to subtract 2. Why, Rick?
One of them is the broadcast, the other one is the network.
Exactly. I subtract 2, 1 for the broadcast, 1 for the network, so then I come up with 254. So this chart is really handy. So I would always just, you know, I always just keep a positional value chart and a host subnet mask chart. That way my brain doesn't have to try to memorize it. It doesn't have to think about it. I just have it, you know. So we can do the same thing, right? We go look for where our subnet mask is, /28. I subtract 2. How many networks? Now the math is the same, but different. Same but different for this. How many networks? Okay, let's do this one together too, because this is one, I know in my class we do it a couple times, but we don't do it a lot. Okay, so this is asking how many networks can I get with a /19, right? Okay, so the /19, what octet does that fall into? The third. So that's the only octet I care about, because the first two I know they're on, right? So let's just look at the third octet. So let's just look at the third octet. And I really don't, the positional values don't really matter. I'm just doing this because we're used to seeing it. 16, 8, 4, 2, 1. Okay, so I have 16 that are on, 17, 18, 19. Everything else is off. And the fourth octet, everything is off. Do we agree? Okay. So if we think about the way we do the math for the hosts, we count up the number of host bits, which are the zeros, right? And we do 2 to the power of 6 or 2 to the power of 4, whatever that is. With the networks, we're going to do the same thing, but just in the octet that we're looking at. So I'm going to do, I've got 3 network bits turned on. So 2 to the power of 3 equals 8. So if I have a /19, I would get 8 networks out of a /19. And what do they increment by? What does a /19 increment by? 32, right? So let's just say I had a 10.10.0.0/19. Okay, so this was my first network address, right? 10.10.0.0. What would my next network address be?
10.10.32.0.
Okay, /19. And what would the next one be?
64.
And what would the next one be? And what would the next one be? Actually, I'm going to do the 0, 0 up here. Okay. 96 plus 32, 128. Okay, what would the next one be? What is it? 160. What would the next one be? 194? 92? 1, 2, 3, 4, 5, 6, 7. What's the next one? 222. Come on, don't make me do it. 9. 224?
Yes.
224. Okay, so we said that with a /19, we could get 2 to the third 8 networks, and we just did it. We just proved it, right? We start with the 0, 0. We increment by 32 to get a total of 8 networks. Now, are we limited to that? We're not. I mean, we could do VLSM and borrow and beg and, get more. But just from the basic math perspective, it's just binary. So 2 to the whatever. If we were doing hosts, it would be 2 to the, if we had a /19, what would it be? if we had a /19 and I was trying to figure out the number of hosts, what would I do? 2 to the power of 13, 8, 13, right? Because I'd have these zeros, right? So I'd have 8, 9, 10, 11, 12, 13. So I'd have 2 to the power of 13. So again, the math is the same there. I have to remove 2 because I have to take 1 for the what, Mark? I have to remove 2 and 1 for the broadcast. Okay, but the way we come up with it's the same. Okay, has everyone got that? So when it asks you for a network, so this is 2 to the what? No. No. How many networks are available with a /16? What octet are we dealing with? Second. How many network bits are turned on in the second octet? 8. So 2 to the power of 8. 256, because what is a /16 increment by? 1. So I'd have a 10 dot, a 10.0.0.0, a 10.1.0.0, a 10.2, a 10.3, a 10.4, a 10.5, 6, 7, 8, 9, 10, because we increment by 1. So you get all the way up to the 10.255.0.0/16. Does everyone see that? We just look at the number of network bits in that octet and 2 to that power. Ooh, you don't have to know this one. If you know it, cool. But you don't have to know this because we don't do this. We don't do it till 160. We used to do it earlier. So the wildcard mask is the opposite of the subnet mask. Okay, so if you have a 255, what's the opposite?
0, 0,
0, right? So this would be 0.0.255. It's just the opposite. It's just the opposite. Okay, a wildcard mask. Good. Right, we can eliminate these two right away, right? Because the 0 is on, or the 1 is off. So we know it's an even. Ooh. Good job. So with this one, my 28, what does that increment by? 16, right? So that means if I could start from the top, I could say 172.16.2.0.16, and then what's the next network after the 16? 32, right? So then I just see, well, where does this fall in the middle? Right? So if I know that a 28 increments by 16, right? So then, and I'm in the 4th octet, so that means I've got, right, that would be one network. What's the next one? Oops, am I missing? Yeah, oh yeah, okay, 28, right? And so then I just say, okay, well, this is an IP address, so where does it fall? Does it belong to 2.0? No. Does it belong to 2.16? Yes, because 2.32 is too big, right? 2.32 is too big. Yep. This one's kind of related to that other one, right? Since we already figured out the networks, just one in front of that is the broadcast. Last one. Ooh. What is the administrative distance of RIP? Come on, Rick. One twenty. Okay, so not too bad. Again, just jot down if there was an area that you're not good at, just jot it down, and then know that you need to allow some time to, practice that, work with me, work with a tutor. If you're not sure where the slash positional values are or how to figure out the network address that, the IP belongs to. And we'll do some more of those practices. But again, this is just to highlight stuff. Hey, Marcus, can you activate this one? Yeah. It's in 150s, week 2. I've already got the date on it. It just needs to be published. Yeah. If you would just go in there. Oh, you know what? Let me do it. I just found it. I'm sorry. I'm already in there. Okay. So just go in and put a text entry box that we did this one in class, right? Just add that we did it in class. You don't need to click on anything. Just put in the text entry that we did it in class. Network addressing, octets, positional values, subnet masks. So let's just look at this for a minute. All right, and then just to yourself, don't call it out yet. How many total networks do we see in this topology? So just think about it for a second. And then there's 2 different kinds. What are the 2 that we see? What are the 2 different kinds of networks that are up there? Go ahead. Let's hear it.
Serial and Ethernet?
No.
Oops.
Those are the connection types.
True.
John?
Public.
You are right. We do have a public, but if we look at just this topology here, how many networks? First of all, how many networks are up here? No, not 4.
7.
Whoa. Okay. Someone give me their answer with confidence. No. Yeah. Okay, so how many? 7. There's 7 networks. 7 networks. Does everybody see that? Okay, so I need a volunteer to come up. So, well, wait, before that, what are the 2 types of networks that are up here? There's 2 types. I hear it. So what is it, Mark?
A local network and a wide area network.
Yes. Is that what you're going to say, Jorge? Yeah, we have wide area networks and local area networks, right? Okay. So I need somebody to come up and volunteer to circle the wide area networks. Volunteer or be volunteered? Okay, make sure you make sure you also get the right interfaces in there, okay?
Wide area is gonna be these.
Perfect. Exactly. Outstanding. And then pass that to Mark. And can you circle the local area networks for us and make sure to include the interface? Exactly right. Why is it important to include the interface? Yeah, exactly, to know where our addresses go. And then for the LANs, that interface on the router is the what? Thank you. It's the gateway. It's the default gateway. It's the exit and the entry point for our networks, right? Good. Okay, now, like John said, we've got a public network up there and we have a private network up there. If we look at this, right, we've got 10.10.10.022 and we have 63.42.0.0/29. Why do we have a public network and a private network? Okay, you're right. Privates are only assigned to certain areas. So what is that breakdown? Where? Yes. Yes. So louder?
LAN is private.
Yeah.
Public is
Right. The LANs are private addresses, right? And here we're on a private address. WANs have to be public addresses. Okay, so we're going to do VLSM, and we have to use 2 different starting network addresses because we need one for the private and one for the public, right? Does that make sense? Yes or no? Yeah, like this is our LAN, so this would be private addressing, private addressing, private addressing, private addressing. And you see here we need 50 hosts, 35 hosts, 20 hosts, and 10 hosts. On my WAN networks, how many addresses do I need?
Just need 2.
I need 2 usable, right? Which would be a total of 4 because I need 1 for my network. All right, let's do another little review. On this WAN, is this interface or this interface called a default gateway? No, they're not. The term default gateway is reserved for LAN networks. And remember, a default gateway, it's just a term for the interface on the router that takes care of my LAN, my exit and my entry point, right? It's just a term, but it's a term that applies to a local area network, not a wide area network. Okay? Let's see. I felt like I had another question. But yes.
Default gateway and, last,
Gateway of last resort.
what does it say?
They're really actually different. And when we get to module 8 and 10, 8 and 10? No, 14, 15, and 16, we're going to talk a lot about the gateway of last resort. So a gateway of last resort is the gateway that we kick the can to, basically. So it's like if me as a router, so I'm a router, and let's say I receive a packet that's going someplace, if I don't have a route in my route table for that route, then I'm going to look for, what is it, Ellie? The gateway of last resort. I'm going to look to see if I have a gateway of last resort. And if I do in my route table, I'm going to kick that packet to the gateway of last resort. So it's actually different. Okay? Okay, so I'm going to hand this out. I want you to circle your networks. Okay, circle your networks. And then we're going to do VLSM. And if you're rusty on VLSM, take one and pass it back. If you're rusty on VLSM, I will help. Oh, why isn't there? Hold on here. Is there something on the back? Oh, okay. I don't know what happened here. Do I have one? Give me a second. See if I have some of these printed. If not, I might have to go print some. What's that? It's let me go print some off. No, it's not that. I'll be right back. Let me just go print some off. I don't know what happened to them. Good job. We're off to a good start. Tricky question. That question is often on the CCNA. Store and forward. What are the two types of cut-through forwarding? The two types of cut-through forwarding. What is it? Fragment free. That's one of them. Do you have the other one, Jorge? Nope. It does rapid frame switching. So we have fragment free. There's one more. So what does fragment free do? What does fragment free switching do?
Checks the destination, it ensures the frame is at least 64 bytes.
Do you know what that means? Exactly. So it looks at the first 64 bits or bytes? Bits. It looks at the first 64 bits. Yeah, I can never remember. It looks at the first 64 bits because statistics show that if the first 64 are correct, the rest is probably right too. So it's called fragment free because it just will look at that. And so that's still faster than looking at everything. Oh, this one's right, this is right, this is right, this, like that would take it a long time. Okay, so fragment free, and then there's one more. It was in my,
As soon as it sees the MAC address, it goes,
yeah, what's it called?
I have immediate, but I
Oh, it's not called immediate. It is immediate. As soon as it sees the destination, it just goes, right? Because it's like, hopefully it's right, but I see the destination, I'm just going to go forward. It's the fastest kind of switching, okay? And again, switches are so efficient these days that that is the default mechanism, is this type of switching. Huh? Nope. I think you might have a chance to get it right or wrong on one of these questions. Yep, cut through, right, obviously, because store and forward means it receives the whole frame, it checks everything, then it forwards it. Nobody uses store and forward. Nobody. I mean, you'd have to have a switch that's 20 years old or older. Ah, there's the answers. We said there's two types of cut through. Oh, fast forward witching. That's the kind on the broom. Okay, so we have fragment free, which is we talked about. It's looking at the first 64 bits. And then we have fast forward switching. That's the one that just looks at the destination. And if you think about the frame, okay, so everyone think about the frame, the Ethernet frame. Which address goes in first? The destination. And that's why. The reason the destination goes in first is for fast forward witching.
Then it's fast forward switching.
Ay, ay, ay. Oh, it's bytes, not bits. I should have known that. That's not the right answer, though. Yep. So fast forward switching just looks at the destination and then puts it on its way. Ooh. It buffers them. It buffers them. So remember window size? Remember window size? So if I'm trying to communicate with another switch, and the switches have the ability to look at the media and detect congestion. And so I will have prearranged, I'm a switch, I would have prearranged the rate at which I can forward frames to another switch, okay? And then it's my job as the source switch to keep that window size going, right? Now, if suddenly that other switch starts getting busy and I see that frames are dropping, the source switch, will change the window size. I'll shrink it. I'll make it smaller so that I send less. But in the meantime, I'm going to buffer. I'm just going to hold on to those until the congestion clears, and then I'll send it. And if it keeps being congested, that's when I change the window size. Okay? Remember that? No? We'll try to do a review, but it's the window size. It's the window size. And there's two different types of buffering. What are they? It's two different types of buffering that the switch can do. So it's a review from 140. I don't know, I can't remember if this module reviewed that. Port-based buffering, which means the port itself has the software built into it to buffer, or device-based buffering, where there's like a cache in the device and it will buffer it. I think the most efficient one is actually port-based buffering, if I remember correctly. Okay? So device-based and port-based buffering. Can you activate this one? Publish it? Okay, yeah. Auto MDIX. An ARP request. Where does it go? Probably
Yes, it does.
goes to the router, goes to the default gateway. How did we do? Whoa, 17 out of 17. Nice job. I'd say anything above 15 is pretty good. That's awesome. Okay, we're gonna do this together, but I want you to fill out everything that you can on your own, okay? If there's something you don't know, leave it blank or write in the box so that you could cross it out and put the right answer in case you get the wrong answer, okay? So it's for the Ethernet frame. So fill in as much as you possibly can. And then also OSI model, PDUs, TCP/IP model, I think is here. Okay, so let's visit the Ethernet header. So the Ethernet header is really important when we deal with VLANs because of VLAN tagging. Whenever we're using VLANs, the VLAN ID goes inside the header. Okay, it goes inside the Ethernet header. Now, this is just the plain header, so you don't need to worry about the VLAN tag. But the reason we want to understand it is because VLANs, they manipulate this header. They don't manipulate it, they just input their tag in there. Bless you. 64 bytes. Bytes, bytes, bytes. Marcus, did you see my email about adding the info to our, thank you. Oh, you did it for all the classes?
I think. I added cloud to
110,
BPC 170 sheet.
that's
so,
fine.
Yeah. I gotta update the name then.
Yeah,
BPC and cloud.
yeah. Or you could either do that, or you could either put it on another sheet, or maybe it would be helpful if you just put what class it was. Like you could do a column for BPC or a column for Cloud 110 and just put a mark in it.
Yeah. I'll probably just make a separate sheet in that
Okay.
case. Because the way I have it formatted is like this. Let me show you. Also, I'm sending a service tag for the virtual machine on this. Doesn't work.
Oh, yeah. You know what? I meant to do that. I tried to get on this one,
This
right?
one, yes.
Yes,
Yeah.
okay.
Pretty sure it's gonna be over here.
Because, like, this summer, I emailed, like, I looked to see anyone who had CNT140, and I emailed those students to promote BPC 170.
Yeah.
If they have 170, I used them to cross-reference.
Yeah.
Uh, So what am I looking at?
This is the contact sheet. This is the way I have it formatted.
Oh, I
right
see,
now.
BPC
Yeah.
170. I see. Yeah, that's fine.
And I can adjust it.
Yeah.
And just make a separate sheet for cloud.
I don't think it matters, no.
Okay.
I don't, in the long run, what would be really helpful, but I don't know how to do it, is if we could have like this person and then we could list, right, oh, she's done 110, BPC 170, CNT one, like all on this, we could see just by looking at her name.
Yes, I see what you
Like
mean.
with a pivot table or something, but I don't know how to do those.
You can, there is a way to do that,
Yeah,
and you code it like a list. I'm not the best with Excel, but
yeah, I don't know. I know it
detect
can,
this name, and I'll create a tab here that lists the
Right.
classes that this name is in.
yes,
Like it looks at this, and it checks the name, and it puts it in this
right.
J column.
Well, if you could ever figure that out, because it would be good if we could just link it,
Yeah, you're right.
because then I could be like, oh, I don't need to send that person anything, they've taken everything.
Yeah,
Or, oh, look, they've already done 140, let's refer 170.
yeah.
Yeah. But I don't know how to do that, Marcus.
I'll try and see if I can do it. Or we can just use Azure and put it all above.
All right, so just do the best you can. When you think you've gotten as far as you can, just pop your hand up. Okay, and then we'll look at it together. Let's see, how far did you get? Oh, look at you. Let's see, yes, 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 yes. Perfect. Oh, I didn't even look at, yeah, I figured you know that. I don't even need to look at that.
All this.
Whoa.
This
You
drawing.
don't know the PDUs, don't send pet for beer?
Well, I was trying to think one of the acronyms.
Don't send pets for beer. You know it.
I don't wanna make mistakes.
Header. Trailer. Does that give you a clue?
Maybe.
Header, data, trailer, and then like this. So like this is like the summarized version, and then like everything that's in here goes there,
Okay.
and then that's there, and then that's there. So like, what would I see inside the header? All right, ready? Let's look at it. Let's see. Dun, dun, dun. Okay. Wait, maybe we want to answer that question. True or false? Service switch or check on the incoming frames. That's true. Okay. Where's my Ethernet header? Give me a second. I'm looking for an Ethernet. There we go. Okay, so this is at the data link layer, the frame, right? The frame. So we've got the header. So this is like just the abbreviated frame, right? So what we have the header and then everything that goes inside the header, the data. Now, this says packet, but in reality, what is inside this middle portion? More than just the packet, right? What else is in there? So remember, we're passing it down. We've got the data at the application, presentation, and session layer. And then what happens to it? It gets what? Gets encapsulated, and it picks up the... So what layer is it at now? It's at the transport layer, right? So it gets encapsulated, and it picks up the what? The port numbers. And what's it called at this layer? What do we call, what's the PDU called? A segment, right? And then it gets pushed down to what layer? The network layer. And again, it gets what? Encapsulated, where it picks up the, louder, Ellie, the IP, the source and destination IP, right? So at this point, it gets pushed down to the data link layer. So all of that stuff is what encompasses the data, right? I've made the pizza and I've put it in the box. Okay, so the packet is in there, but also the segment, everything's in there, and it got pushed down to the data link layer. Okay, so what we've got, our Ethernet header is made up of the frame. Hey, this is where we're going to start. The addressing, which is going to be the destination and the source, what? MAC address. The type, now what is the type referring to? I hear two answers. It's if it's IPv4 or IPv6. The control is the media. Yeah, right? Because remember, the data link layer, it has to know, well, am I going to be putting this frame, does it go on fiber optic? Is it going on a radio frequency? Is it going on Ethernet? Okay. And then we have error detection. Now, with error detection, that fast forward switching, it never gets to the error detection, right? It's like, oh, well, I'm hoping for the best. What I care about is speed, right? Whereas store and forward gets all the way through, and then the stop, okay? And then the stop. Okay. Now, when we're doing VLANs, okay, when we're doing VLANs, does the PC know what VLAN it's part of? It does not. It does not. So if I've got these PCs attached to the switch, okay, so none of your PCs, let's say you guys are VLAN 10 and you're VLAN 20. No, you don't know that, right? So when it's connected to the switch, I have had to tell the switch port mode access, right? And then I have to tell it what VLAN it belongs to. So yours would be VLAN 10. Okay, so when the frame comes in and it starts to build the MAC address table, it plugs the VLAN tag inside the header, goes right in here. So if it's part of VLAN 10, it's going to just pop it in here. If it's part of VLAN 20, it's just going to pop it in here.
So when you say tag, that means VLAN 10 is the tag number.
Exactly.
20 is the tag number.
Exactly. 33, 102, whatever the tag, whatever your VLAN number is, in binary, it's going to pop it inside the header. Okay? So let's think about something. So we said that the ports have two jobs, either an access port or a trunk port, okay? So if I have a switch, and I have VLAN 10, VLAN 20, I have VLAN 10, VLAN 20, okay? What do I need to put here for these guys to be able to talk to each other? I got to do a trunk, right? And trunks carry what kind of traffic? VLAN traffic. So VLAN 10, this computer, comes up here, it picks up the tag, right? It goes through the MAC address table just like normal. The MAC address table doesn't care about the tag. The tag is important right here. So I'm like, oh, okay, so this computer is trying to talk to this computer. So it hits this port, and it says, oh, I see the tag on there. It's VLAN 10. Can I send it across? I can send it across, right? I look at the MAC address table. I know where to send it to this port. This port de-encapsulates it, peels off the tag because this PC doesn't care about it, and it sends it to the PC. So the tags are used in order to get the VLANs and the traffic to the right computer, the right destination. Okay? Because remember, if I have a network here, VLAN 10, and I have and a sales office, VLAN 10, and I have a sales office in Colorado, VLAN 10, can they talk to each other? Yeah, they can, right? Because as far as they're concerned, they're all just part of the same network. It doesn't matter that one's in Phoenix and one's in Colorado. All it's looking at are the tags. Hey, this is part of my family. Okay. All right. So let's see, we're going to start with Melanie. We'll do this. And then we're going to look deeper at VLANs. Okay, so which one of these contains the IP header, transport layer PDU, and the data? So if we're looking up here, where would I find the IP header, the transport layer PDU, and the data? Well, just here, like which one of these sections? Are you sure? So if we're looking at these sections, which one of these sections would I find the IP header, the transport layer PDU, and the data? Nope. No. So if we're moving down the OSI model and getting things encapsulated, and here's my frame, right? Here's my frame. The frame is made up of the frame start, addressing type, control, data, error detection, and frame stop. Where would I find this stuff in these sections? No, not the, just in these sections. Is it, so would I find an IP header in the start of the frame? The IP header? No. Jacob? Rick?
Say no, but
Where is it?
addressing?
No.
Are you saying like the IP headers in the type?
No.
Or all of them?
Okay, so just a second, time out. Yes.
When you were just talking about going down layers and encapsulating everything, would all of that stuff be in data?
Yes. Yes. See that? Okay, so this is asking where would I find this? So think about encapsulation. I start out with the presentation, the application presentation and session layer. I'm typing a big email. Okay, everyone got that? I got a great big huge email. I've attached a PNG, a JPEG to it. I'm going to send it, right? That's the data. Do we agree? That's the data. That's the PDU called the data. Now, where does it have to go after the application presentation and session layer? Where does it go next? It goes to the transport layer. What happens to it?
Encapsulated.
And what does it pick up? Ports. And it's called a what now? A segment. It's called a segment. Okay, now this segment gets pushed down to what layer? The network layer. And what happens to it? And it picks up a source and destination IP. So what layer are we at? 3, layer 3, the network layer. And it's called a what? A packet. Now it gets pushed down to the data link layer. It becomes a frame. It gets encapsulated. And it picks up a header. So this stuff has just been pushed down. It picks up a header. So what's inside of here is everything that came from the top. So when it says where inside the frame, where inside the frame would you find the IP header, the transport layer PDU, which is the what? Segment, and the data. Everything that started at the top, right? So this has all been pushed down. So where would you find it? Would you find it in the frame start? No. Would you find it in addressing? No. Type? No. Control? No. Yes. Exactly. Exactly. See, this stuff is part of the the frame, the real frame. It's required in order to move, right? But it's wrapping everything up so it can be transported or moved across the media. Got it?
Yeah, so as it moves down, the data keeps getting bigger.
Yeah.
It's got all those layers.
It has all those layers. Hi, Damon. Okay, so then it's at the data link layer. What layer does it go to next?
Physical.
The physical layer. Now, from the data link layer, think about this question carefully. From the data link layer to the physical layer, does it get encapsulated again? No, it doesn't. But what happens from the data link layer to the physical layer, Oscar? Nope. Encoding. Encoding. So remember, the computers, routers, and switches, they're talking in bits, right? However, if I get put down onto the media, that means I'm going on fiber optic, Ethernet, or radio frequency for Wi-Fi. Does a fiber optic cable understand ones and zeros? What does it understand? Pulse, on or off. So the ones and zeros have to be encoded into a format that the fiber optic cable can understand, which is light. If it's being put down onto a Wi-Fi or a radio frequency, it has to be encoded into waves. If it's going onto Ethernet, it has to be encoded into electricity, on, off, on, off. We got it? Then it moves across the media. It hits the NIC card. It has to be picked up, moved up to the data link layer. Now, what happens to it? It's not encoded, it's decoded. It changes it from light back to ones and zeros, binary. And then it starts to de-encapsulate. It's like, let me see, where was I going? What's the destination MAC address? Where's that coming from? What's the frame start? What's the CRC, right? It's peeling off the layers. And then it's like, okay, this has to go someplace else. I'm going to push it up to the network layer. It de-encapsulates it, right, until it gets to where it was going, which is Joe Schmo's email. Okay? All right. Jacob, identifies IPv4 or IPv6 as the network layer protocol. So is it the frame start, the addressing, the type, the control, the data, the error, the frame stop? It's the type, right? It's the type. Because when it comes down from the network layer, we're either using the protocol of IPv4 or IPv6, and it just wants to know what type it is, okay? Just wants to know. It doesn't really do anything with it. It's just information that it needs. Rick, a set of bits checked at the destination.
Control.
Look again. At the destination. It's checked.
I almost want to say error detection there, but that's all.
Say it with confidence.
Error detection?
Error detection, right? So I'm going to say, hey, I'm going to be sending over 1,500 bytes of information. Okay, well, let me check it. Let me check it. Now, it only counts. It doesn't know if it was sent in the right order. It doesn't know if it's the right information. It just knows, oh, I'm supposed to get 1,500 bytes. I got 14.99. That's all. Okay. John. Flags to indicate the beginning of a frame.
Frame start.
Frame start. Ellie, indicates layer 2 addressing. Addressing, right? Because we're dealing with layer 2 frame, it's the addressing. Oh, that's it. Darn it, I didn't have one for everybody. Let's see, forwarding, preamble, okay. Who's printing? Maybe Marcus? Oh, that's weird. All right. I don't know what that is. I mean, I know what it is, but. All right, so let's talk a little bit about VLANs, and then I want to, I'm hopefully we'll do something else. So does everybody have one of these? So in this scenario, how many networks do we have?
4. Oh,
Are you sure?
no, I'm sorry. 1.
So this one right here, this worksheet, how many networks do we have? 3. Not a trick question. Sales, manufacturing, and the warehouse. So in the first assignment we did, everything was on its own network, right? Or on its own router. Well, one of the reasons that we want to learn how to use VLANs is so that I don't have to spend a ton of money on routers. Okay, I can segment my switch. Now, would any of these networks be able to talk to each other the way that this is currently laid out? Would they be able to talk to each other? No. Why not? They're on different VLANs, and one other reason. There's no router. There's no router, right? So remember, we have to have a router in order to talk to another network. So, and that's where we're going to move towards. That's where we're going to move towards. Okay. Now, in this scenario, I've got this great big broadcast domain. They're all part of one network, right? The 40 network, the 40 network. So I've got this big broadcast domain. So I've got there's a greater opportunity for failure, right? Because if I have one link go down, I'm going to take down more than if I had multiple segments. So here, we're just going to use VLANs to segment. And again, this could be in Colorado, New Mexico, Arizona. Do they care? They don't care. They don't have any idea. Okay, so one of the main reasons to use VLANs is to limit the size of our broadcast domain. Okay, we limit the size of our broadcast domain. And in this scenario, we're running 2 different VLANs. Okay, now VLAN 10 is faculty. So even though it's on the same switch, could it talk to the students? No. It can't. Once again, what do I need to add to this in order for them to all talk to each other? Yeah, I would need to add a router, right? So my broadcast domain is just limited, right, to everything in that VLAN. Okay. Now we talked about the difference between an interface VLAN and just a plain old VLAN, right? So what's the difference? What is the difference between an interface VLAN and just a regular VLAN? Yeah, interface VLAN is when I want to set up an IP for management. Because a layer 2 device functions at what layer? A layer 2 device functions at what layer? Layer 2. And MAC addresses function at what layer? Layer 2. So if I'm in Hawaii and I need to get into my switch, if it doesn't have an IP address, can I do that? No. Right? If I need to pull information from it, I can't do that. So the only time we assign an interface address is when I need to get into it. I need to do something to it, or I need to pull information from it. because these three switches, they'll work just fine with or without an IP address, right? They'll move the frames, they'll forward frames. I just can't get into it remotely. Okay? Now, in this scenario, again, faculty can talk to faculty, VLAN 20 students can talk to students. Now, what I might want to do if I want to be in Hawaii and I want to set it up so that I can be in Hawaii and get in here and manage the networks, I might make these switches part of their own network. Okay, so just mull that over. They're just part of their own network. They're going to function like an end device. So just like I need to put an IP address on this in order to email it remotely, you know, if I'm in Phoenix and this is in Colorado, I got to have an IP address. These, whenever we're putting an IP address on a switch, it's just basically going to function like an end device so that I can push information to it, pull information from it, okay? Now, notice here, this is part of VLAN 100. Could it be part of VLAN 40 if I wanted it to be? If I wanted to call it VLAN 40, I could call it whatever I want. Anything I want. Now, the other thing, maybe I have a trusted faculty person that knows how to get into the devices. Instead of putting it on a separate VLAN, I could assign these an IP address from VLAN 10. It's just making them an end device. That's all it's doing by giving it an IP address. So this one is 172.17.10.21. I could make this one 172.17.10.40. 41 and 42, and that means somebody in the faculty would be able to get into these devices to do stuff. Okay? That's all it is. It's just if we need to manage it. You can make it part of its own domain or part of an existing domain. It doesn't matter. It doesn't matter at all. Okay? Frankly, I don't want my faculty messing on my switches. Right? I don't want students getting on the switches. I only want someone from my IT department, so I'm going to give it an address from the IT department. Does everyone understand that? Okay. So, how do we do it? Interface VLAN 100. I assign it an IP address, no shut, just like I would assign anything else. Okay? Just like I would assign anything else. Now, in this scenario, notice I don't have any virtual LANs out here that's part of 100. It's literally just the switches. It's just the switches. Okay? It's just the switches. Okay, so how would I do a description on this?
You should just say this is a management VLAN used to access remotely.
Okay, so let's do switch 1. So how do we do the description on switch 1 for a management? Oscar, I'll help you with this. I know that you've probably never done that. Ellie, let's hear it.
VLAN 100 is the management VLAN on network 172.17.
Okay. Wait, let's back up a little bit. Okay, so source device, what's the source device? Okay, so remember, a description is the source device, right? So description is switch 1, right? So source device and port, what's the port? Interface, VLAN 100. Connects to destination device and port. Is there a destination device and port? There isn't. It's a management. And then what? 172.24. source device and port connects to destination device and port, if there is one, and then the network. Okay? Now, as we start to do descriptions, you're going to want to include, like, for faculty, it would be like VLAN 10 faculty. All right? Help your future self. Help your future self. Yes?
So this is just strictly just the VLAN, not the interface.
This is just the VLAN. Well, no, this is the interface VLAN.
That's where I'm getting myself confused. Because of the interface VLAN we're talking about, then we're talking about VLAN, now we're doing the.
Yeah, all we're talking about is the interface VLAN. So let's do F18. Okay, so let's do the description for F18 on switch 2. Okay, so right here, we're going to do this.
S2,
Okay, so it would do description S2,
interface is F018,
F18.
and then you're gonna say the destination, or was it 2?
Okay, so 2.
Um,
Yeah, let's just call it VLAN 20 because it's going to, I mean, we could say PC2, so let's say VLAN 20. Yeah, and I'm gonna go ahead and say student, okay? I'm gonna say student, and then the network, 172.17.20.0/ I think it's 24. Source, device, and port. Now, in this case, chances are, am I only going to have one student PC? No, I mean, I probably have a bunch of them, right? So let's just say that it's connecting to VLAN 20, because I probably have more than one. If you say PC2, that's okay too. Okay, now, how do I do... Let's do here to here. Okay, so Jacob, you want to give it a go? Okay, so we'll start with, so we have the word description, S1.
On interface
F01. Connects to, so it's right here, we're doing here to here. Switch to. See, that's not a VLAN, it's a trunk, right? We're connecting F01 to F01. It's a trunk. So S1, F01 connects to, Mark? Switch to. F01. So now what? Yeah, well, does it just carry VLAN 100? It's carrying whatever, right? So here's what I might do. Okay, there's a lot of right ways to do this. S1, F01 connects to. Now, I might also just say trunks to, because then I know I've set it up as a trunk. Both ways are right. Okay? I'm just saying, where am I starting? Where am I finishing? Okay? Now, I'm going to look at this and I'm going to say, well, what traffic am I carrying? VLAN 10, 20, 100. Right? Just, again, you need to help yourself if something fails. And again, I am an overkill person. I do more, not less. So mine would say trunks 2, and then I'd say VLAN 10 students, VLAN 20 faculty, VLAN 100 management. Now look, you might be working on a network that has 50 VLANs. I'm not going to write out all 50 VLANs. I'm just going to say trunks with VLANs. Right? But if I have a small little network that I'm trying to manage, more is better. source, device, and port, where it's going, what the network is. Now, same thing here. I might even add networks, because again, more is better, right? So I'd say VLAN 10 students, 172, 17, 10, 20, 24. I'd put the faculty. More is better. I do not want to be like, oh, crap, this network's down. Let me just thumb through all my information and see if I can figure it out. It's just not my style, you know? Okay? There's our description, I didn't have enough room to put the whole description, but, okay? So let's see. From each network, this allows. All right. Interface VLAN. So there, it's just me adding an address, right? .3, .4. Now it's all part of its own network. It's functioning just like an end device. Now, because it's functioning like an end device, what else do I need to tell those switches? What else do they need to know?
Your default gateway.
Yes. Yes. If you set up an IP address on this device, what do you have to tell it?
Well, IP address.
So IP address, it's
It's mask
subnet mask.
and its default gateway.
So when I use this, I give it an IP address, I need to tell it what its default gateway is. And it doesn't have a nice, easy control panel, right? We have to do it through the CLI, IP default gateway 172.17.30.1. Okay? Let's see. All right, so everyone, what kind of port is this?
Access.
How about this one?
Access.
This one?
From.
This one?
From.
This one?
Access.
Okay? What's the command for access?
Switch port mode access.
Switch port mode access, right? Telling it, you got to tell it what its job is, and then you have to tell it what? After you tell it its job, then what? Okay, what else? Switch port mode access. Now what do I have to tell it?
Oh, what VLAN it has access to.
What VLAN it has access to. What VLAN do you belong to? What VLAN do you belong to? Right? Otherwise, remember, it can't get that tag inside of its header, and then it won't know where to go. Okay? So there we have it. Interface F11 right there. Switch port mode access. Switch port access VLAN 10, no shut. We're going to tell it what its description is. F18, switch port mode access. So here's your job, and here's what VLAN you belong to. Okay, here's what VLAN you belong to. Remember, this VLAN will be used in the frame header so that it knows where to go, how to find its friends. Can't find its friends unless it has that. Okay, can't find its friends. Don't forget that all active interfaces need descriptions. All active interfaces need descriptions. And if you want to be a good achiever, put it on your shutdown ones too. Shutdown per network administrator. Right? Ask permission before you turn them on. So, trunks carry VLAN traffic. What's the command that I've got to put on F01, on switch 1 and switch 2? Switch port mode trunk. Yep, switch port mode trunk. Okay, so I got to tell these guys that your job is to behave as a trunk. Now, there's another command, there's quite a few, but there's another one we could use if I want to limit the VLAN traffic to a specific VLANs. What command would that be? The allow statement. Okay, the allow statement. So I want to tell you something about the allow statement and also the native VLAN. Okay, So the native VLAN is to take junk traffic. It's a very good practice. If you're a good network administrator, you'll always put the native on there. Okay. If you don't have an allow statement, that's cool. It's no problem. It just allows any VLAN. There's nothing wrong with that. Okay. Now, if you want to lock your network down a little bit, you can add the allow statement. So in this scenario, I could say just allow 10 and allow 20. The advantage of that, if someone comes in there and pops in a VLAN 33, right, it won't work because it's not part of the allow statement. Something to remember is an allow statement, it is not a security mechanism. Like, it's not there for security, but does it give your network a little added security? It does, but it's not a security feature. Like, that's not the reason that we use it. That's not the reason the allow statement was designed, but it does give your network a little added security, okay? My advice, I think this happened to us. My advice is get your whole network working before you add in the native VLAN or the allow statement. Because once you add in the native and once you add in the allow statement, you start to impose some restrictions. Well, it's always a good idea to just make sure your network works first. Because otherwise, if something doesn't work, you're like, well, is it because I did something wrong 20 minutes ago? Or is it because I put on this, jacked up allow statement? Like, what have I done wrong? Just get your whole network working. Then go add the allow statement, test it. Oh, this is working. Then go add the native. Oh, great, this is working. Just do a piece at a time, right? A little time up front saves you a lot of time in troubleshooting. Okay, so we already talked about how to do the description. So just some handy VLAN show commands. Okay, show VLAN brief is probably the best one. If you want to look at a specific VLAN, you can look at show VLAN and whatever the number is. It's also helpful to look at the specific interface. Okay, so just some helpful VLANs. Okay. If you're not in the VM, can you get in the VM? Okay. So let's take care of some administrative first. Did we already put the message in for the Kahoot switching? If we didn't do that, put the message in for the Kahoot switching that we did it. Put the message in for the Ethernet header that we did it. You want to memorize that Ethernet header because I'll be asking you about it a lot. All of these are under week 2 class activity Monday. You might need to refresh your screen. Yeah, you might have to refresh your screen. What is it? Oh, Marcus, are you in there? Can you take the Ethernet header, can you make it PM? Good grief. Honestly, I don't know how to fix that. And then the circle, like just, I just want to make sure everybody gets their credit and that I don't forget to, put your points in there. That's how I remember to put your points in there. And we're going to work on this together right now, okay? We're going to work on this worksheet, packet, demo, part 1, VLANs, compare VLANs. So once you've added your little notes in there, yes. Yeah. Yeah, just keep refreshing. And actually, let me make sure. Oh, it says submit on paper. Okay, then that means we can do it. Yeah, don't worry about it. Let me see what this one says. PM. Okay, of course.
You want me to just set it to...
Yeah, you can set it to text entry. I don't know how it works when it says paper.
It just, there's no submission whatsoever.
Oh, that's fine. It doesn't either way.
Yeah.
It's fine. I just like it when the line goes through so you can see that it was done. That's all. All right, and then we're going to do this one, class activity, part 1, VLANs, compare VLANs and interface VLANs. So, again, this is the topology we're going to be working on. Okay, so we've got a VLAN 10 and 20, 10 and 20, 10 and 20. Now we're going to work on this throughout till the end of the night tonight, and then we're going to work on it again Wednesday. And then we're going to probably work on it again next week, because will these VLANs talk to each other? No, but next week when we learn about inter-VLAN routing, we'll add a router and a trunk. We'll add a trunk and a router, and then we'll make them talk. Okay, so we're going to build on this. So let's go ahead and we're going to open up the document, and we're going to open up the packet tracer. When you've got both open, can you just pop your hand up so I know that we can start? Did you find it, Oscar? It's under class activities.
The same place you found the Word document, just above it.
See right there?
Oh, okay.
So this packet tracer's already been made.
So it's gonna, how do I open it up over here?
You have to be in Canvas.
You can actually,
Oh.
if you download it from there, go into your downloads folder and File
Oh.
Explorer, and then click
Drag it
to the-
over.
yeah, that's the benefit of having it on one screen. Or you can copy and paste it. I've done it before as well.
That would work. All right, so is everybody in there? Mark, Jorge, you in there? Okay, Jonathan, John, sorry, Jonathan, John. I have a Jonathan in my other class. All right, so what type of traffic will a trunk carry? VLAN traffic, so answer the question. All right, so you're just filling this out. What's the command to turn a port into a trunk?
Just port mode trunk.
Yep, switch port mode trunk. So then you're going to answer these 4 questions, right? If the PC is connected to a switch and it's part of a VLAN, what do you have to do? What do you have to tell it? No, that's not what you tell it. Aren't switch ports already on? Aren't they? Huh? Yeah, they're on. When you open up a switch, it's on. You don't really have to tell it no shut. But what do you have to do? So if I plug your computer into the switch and it's part of VLAN 10, what is that port, right?
You have to assign the VLAN to that port.
And what else do you have to do? There's 2 things you have to do. We just went over it on the PowerPoint. F18. You have to tell it what?
Oh,
You have to tell it that it's a,
Access port,
and then you have to tell it
what VLAN.
what VLAN it belongs to. So that's what you're putting right there.
So you assign a VLAN port, and then which port mode access?
So what's the first thing? So right here, let's say this is F010. And it's connected to this PC6 for VLAN 10. So I have to go interface F010. What's the next command?
Name. And name VLAN.
Well, this PC is connected to, let's just say it's I don't know what it's connected to. F010. This PC is connected right here. This is VLAN 10. So I'm going to go into interface F010. What's the next command?
Switch port mode access.
Switch port mode access. I have to tell the port what?
It's an access port.
What its job is, that it's an access port. So switch port mode access. What's the second thing I have to do? Right, I have to tell it what VLAN it belongs to. So if a PC is connected to a switch and is part of a VLAN, what must you do in order to allow traffic through the port that it's connected to? You have to tell the port that it is a, what kind of port? Access port, and then you have to tell the port what VLAN it belongs to. It's not a trick question.
Just a tricky process.
Okay, and then when you get, then you're going to explain the difference between the VLAN and the interface VLAN, and then just stop. Okay, just stop there so that we can do the rest of it together. Just stop. I know that you're tempted to race ahead, but just slow it down. Ellie, John. I know you two. See? You're like, eh. Once you've answered those questions, just pop your hand up and then we'll all move on together. Make sure you get the answer right since I told you the answer. Thank you, Melanie. Thank you. Okay. Ellie, Rick, okay. Done? Okay. Done, Mark?
I think so, yes.
Okay. All right, so let's just look at this next piece. So on switch 4, so here's our switch 4, using the banner message and interface descriptions. So what that means is you're going to find information about what you're supposed to do by reading banner messages and interface descriptions. And you may have to do it for more, you might have to look at more than one switch. It's hard to say, okay? You're going to add VLANs 10, 20, and 33 to switch 4. So on this switch, we've got a PC for VLAN 10 and VLAN 20. I'm assuming that just because we're seeing them there, maybe the ports aren't set up. So you're going to have to figure that out, okay? And then you need to set the trunk link between 3 and 4. Okay, you need to set the trunk link between 3 and 4. So where are you going to look to see what ports to use?
Yeah. About the ready brief on a switch.
Maybe.
The topology
That might tell you, but maybe you should instead follow the directions using the banner message and the interface descriptions. Okay, why do I say this? Because I know you all. I know how you are, Rick,
Yeah. Yeah.
right? So I'm pretty sure, I haven't done this assignment in 6 months or less, but I'm pretty sure all the information you need is somewhere inside this device, okay? Now, you're setting the trunk link. You're going to set an IP address for VLAN 33 on switch 4, okay? Set IP addresses for the PCs, okay? And then you need to create accurate descriptions. So notice how it says new descriptions. That tells me that there's probably some descriptions in there to help you, but you got to put accurate ones in there, okay? So let's just see how far we can get. It's 8:45, but don't rush, okay? Because when you rush, you're going to make a mistake. Just slow it down, okay? And then the goal is to get some things pinging. Now, is everything going to ping? No, it's not. Not everything's going to ping. So when it asks you here to copy and paste your results, if you ping from VLAN 10 to VLAN 20, is it going to work? It's not going to work. So don't freak out. It's not supposed to work, right? But we'll get to that point where we'll eventually make it work. Okay? So let's see how far we can get on this. Okay, this is how clear the message is. Jacob, read that.
Student, set this to trunk.
Okay. Don't guess. Right? Can I add you to them? Yes. Silly, silly, silly. Hi, ladies. Troublemakers. Good. How's it going with you? Yes. Working on a little packet tracer. How was it?
We went in there and it's like all these like new terminologies and
I'm Zen. I don't want to do it.
What?
she's like, I'm dropping out.
No, 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 no.
Just
No, because by the time you're done, you'll know so much more for 150. Melanie did that. Melanie took a 171 and now she's in 150 and she said it helps so much. No, it'll make it so much better.
It was just so overwhelming. I was like, all these concepts and terms. We
she's
did our,
being dramatic.
She's being dramatic.
we did our practice exam and I got a 35. I was like,
That's not bad. That's actually not bad. Because think about it, you've only had one class out of 3,
Yeah.
so that's a third.
so then that's
That's how she's like hyping herself up.
yeah. I'm like, that's how I'm gonna prepare.
And you're not, like, they're not looking for you to get 100 or anything.
She's so sweet. She's like, don't stress. Leslie, she's like, just do what you can.
Yeah.
She talks. She's like very.
We're
She's so
doing
sweet.
cahoots and I was like, just put on the music.
You guys traumatized.
You guys.
And then Damien was like on our Tuesday and Thursday class. He's like, we are gonna do cahoots, and I was like, oh my god.